Hello, everyone. Thank you for joining our webinar this morning. We are back with another great presentation for you today. My name is Misha Lalu, and I am the marketing specialist for DynaEnergetics, and I will be your host for today's webinar. Our panelist today is Oana Carroll. Throughout her career, Oana has held several various technical and management positions on both the service side and the E&P side of the business. She recently joined DynaEnergetics as our market development manager, and she is based in the Pittsburgh area. So Oana, thank you so much for being here and for joining us today.
Well, thank you for having me.
So I would like to quickly mention that the DynaEnergetics LinkedIn page is where we first announce all of our upcoming webinars. So if you don't already, please go ahead and go to our page and give us a follow. Following that page is a great way to stay up to date on all of our events, all of our upcoming webinars, our new products, and of course our new technologies. And as this is our last webinar of the year, I would just like to thank everyone for attending our webinars this last year. We will definitely be continuing this webinar series next year. And so we are definitely looking forward to continuing to share with everyone more on our technology, our products, and our systems. So as you all know, the topic for today's webinar is in-plane perforating, or single plane perforating, as it is also referred to. We will be discussing what in-plane perforating is. We'll talk about how the solution can help overcome some common industry challenges, and then we will transition to talk about how our DS Trinity System can address in-plane perforating. So if you have any questions throughout the call, any questions about in-plane perforating, questions about Trinity, just general questions for Oana, please make sure you're typing them in the Q&A function, which is located at the bottom of your screen. You'll see a Q&A button, so go ahead and hit that, and you can submit your questions that way. We will be monitoring all the questions throughout the presentation, and then we'll save some time at the end to address any questions that you have. So we're just going to go ahead and jump right into it. Oana, our first question for you today. So for the audience that might not be familiar with in-plane perforating or single plane perforating, can you just talk to us and explain what it is, and then talk about any value that it can bring?
Oh, absolutely. So yeah, just to get everybody on the same page, when we talk about single plane perforating, is known also as an in-plane perforating, is a fairly new perforating strategy applicable for unconventional reservoir, where all perforations are placed in the same plane radially around the wellbore for each cluster, unlike the conventional perforating, where the perforations have a spiral or helical pattern around the wellbore. So with this single plane, really, it really helps initiate and guide the fracture in the preferred fracture plane.
So thank you for that quick explanation. That'll kind of be helpful to have a quick reminder on what that is as we continue throughout the presentation today. So can you talk to us now, how do you think single plane perforating compares to maybe other more traditional solutions? So just talk about the differences, and then maybe just explain why we think single plane perforating is a better solution.
Yeah, so in order to address that, I'd like to take a moment, and we're going to talk about fracture initiation and propagation. So we all know, so the fracture initiates at the perforation and propagates along the path of least resistance, which is perpendicular to the minimum horizontal stress. So when the perforations are staggered helical along the wellbore, the multiple competing fracture could initiate in the same time in multiple planes. During the treatment, these fractures develop and they compete. They could also reorient, and they connect further from the wellbore, resulting in a very tortuous fluid path that affects the wellbore to formation connectivity. And we're going to see further later on in the modeling what the other downsides of that is. But when the perforations are placed all in the same plane and they're all equal entry hole, the perforations link up radially around the wellbore, and one predominant fracture initiates and propagates across the perforations, allowing equal distribution of treatment pressure and equal volumes of fluid and proppant throughout the treatment. Moreover, when all the perforations are in the same plane, They also see the same pressure drop, and as a result, it's more likely that all perforations open up in the same time, which results in an increase in perforation efficiency. So to summarize, standard helical or spiral perforating pattern guns can cause multiple competing fracture in multiple planes, while single plane perforating allow initiation of a single transverse fracture in the preferred fracture plane without the tortuosity and the pinch points.
So you mentioned just now single plane perforating versus helical perforating. You talked about some of the differences between the two. So can you now talk about the impact and share any results that we might have comparing these two solutions?
Absolutely. We'll jump right in. There are obviously few studies and papers addressing the single plane perforating. They came out in the last couple of years. So one study I would like to mention was conducted by the Shell engineer and prepared for American Rock Mechanics Association. And the study focuses on polyaxial experiments on isotropic cement sample, where the principal stresses were set to simulate and represent a horizontal well in a normal faulted stress regime. So the result of this study really shows that the breakdown pressure can be reduced by 25% with the in-plane perforating. Obviously, that depends on the formations that we're treating. And also, another interesting finding was that the conventional helical perforating leads to more near wallbore fracture tortuosity, while single plane perforating results in a clean transverse fracture and all the perforations, they link up radially. Another study I would like to mention addresses the impact of a single plane perforating on near wallbore fracture geometry through the development of a 3D finite element model. This sensitivity study shows very similar results in the sense that in helical perforating creates complex and tortuous near wellbore fracture geometries. They're obviously undesirable since they can impact the wellbore to fracture connectivity. While in plane perforating, having all those perforations in the same plane helps guide the fracture trajectory towards the preferred fracture plane, reducing the tortuosity and ultimately improving the efficiency of hydraulic fracture treatment. Same study also shows that in-plane perforating, actually similar to the previous one, can reduce the fracture initiation pressure by 200 psi, again, depending on the formation that we're treating. So when we look at these studies, it's really, we keep on bringing up the tortuosity. And why tortuosity is undesirable is because it really creates a pressure drop. So tortuosity in the near wellbore, it creates a pressure drop and increases the average treating pressure. So if we look at the quick simulation results for a Permian well, a base case with no tortuosity versus tortuosity, so simulating a single plane versus conventional helical, we can see quite a few hundred psi difference. So we can actually decrease the average treating pressure through the use of single plane perforating and eliminating that tortuosity aspect. Another thing about the fracture tortuosity, the reason that is undesirable is because it impacts the wellbore to fracture connectivity, both during the fracture treatment as well as during the production. So by reducing the tortuosity and the pinch points results in a better perforation and cluster efficiency and a more uniform and propant and fluid distribution, which really ultimately translates in a better fracture geometry distribution along the wellbore and a better fracture conductivity, which that's what we're all shooting for. So if we, internal simulation, we try to compare side-by-side single plane perforating versus a case with tortuosity. So if we look at the slide shows a fracture conductivity comparison for a 10 cluster Permian well, simulating the single plane on the left and as a base case with no tortuosity versus another 10 cluster design on the right with a tortuosity component. So when we look, the graphs display the fracture conductivity with the brighter color being indicative of fracture conductivity. So the results clearly shows better fracture geometry distribution for single plane perforating, which is on the left-hand side of the graph, as well as higher fracture conductivity, the brighter colors. So better wellbore to fracture connectivity and a more conductive flow path for the single plane case.
Thank you for that explanation, talking about the impact of the two different solutions. Those visuals and graphics you provided definitely helped as well. So thank you for that explanation. So can you now talk us through some of the benefits of single pane perforating and maybe talk about how it can help overcome any current challenges faced?
Absolutely. So we talk about different things, what the single plane perforating does. And one of the things that the studies I mentioned found was that we could reduce the breakdown pressure by using single plane. And really, the benefits of that is that it could be a time-saving component, meaning less time to achieve the design treatment rates, as well as also a cost-saving component if we think during the fracture treatment that we can use less chemical and water to actually break down the formation and be able to achieve the design treatment rates. Another big component and another big benefit was lowering the average shrinking pressure by eliminating the tortuosity component. So really that has a huge impact and a huge benefit by avoiding screen out and ensure successful treatment, especially on formations that are very deep or high pressure formations. As well as less horsepower required and less wear and tear on the equipment, which equivalates to cost savings. Last but not the least, obviously, is the improved near wellbore fracture geometries, as we've seen in the previous slide. And with a single plane perforating, we reduce the tortuosity and in the near wellbore, and as a result, we enhance the interconnectivity of reservoir and wellbore with a positive impact on productivity.
Thank you for walking us through those benefits. So now that we know the benefits, I'm curious, you could talk about the possible applications.
Absolutely. So when looking at the benefits and where do we see that these fits, there are multiple applications that we can see the benefit of running single plane. I'm going to start with a limited entry application because that's one of the main applications for unconventional reservoir. And really by using single plane, it really results in a higher perf efficiency and higher cluster efficiency by seeing the same pressure drop across the perf. Another big area that could benefit from single plane, there are the deep formations that are also usually high pressure completion zones. In this case, we can, by reducing the average treating pressure, we can minimize the risk of premature screen out or the risk of failed fracture stages due to the high pressures. Last but not least, there are the clastic and the ductile rocks. Those are usually tend to be harder to break down and also usually harder to keep the fracture open on those formations. So by being able to reduce the breakdown pressure and being able to break down those formations, single plane could really be a good applicability for these formations, as well as being able to reduce the average treating pressure. We can actually increase the rate that we can treat those reservoirs and thus being able to keep that fracture open longer and minimize that tortuous path in the clastic rocks.
So I just quickly want to remind everyone, if you do have any questions, again, make sure you guys are submitting those questions through the Q&A function. Again, that's located at the bottom of your screen. So we'll have some time at the end to address any questions that you have. But want to thank you for that explanation, walking us through. I'm sure we now all have a better understanding of in-plane perforating. And so now that we've talked about those benefits, I'd kind of like to transition to talk about how all of this information relates to DS Trinity. So as I mentioned earlier, DynaStage Trinity is the dyna-energetic solution to address single plane perforating. So Oana, could you please now talk us through DS Trinity, talk about the system's features and maybe the benefits as well?
Absolutely. So DS Trinity, as you mentioned, it is the DynaStage solution for single plane perforating. And it is really a compact modular perforating solution that comes in with 3 charges in one plane, as well as the other version is available with 6 charges in 2 planes that are like back to back. The gun is available, the DS Trinity is available in both 3.5 and 4-inch OD with a 7-inch and 8-inch length. So it is a subless unibody design for length optimization. And the great thing about DS Trinity, it uses similar manufacturing process as the rest of Dynastage family, a fully factory assembled gun system, which really means a high quality gun that is easy to arm and test, while also delivers great reliable downhole performance. So I mentioned the unibody design for length optimization. So DS Trinity is significantly shorter than any other conventional perforating gun, and even significantly shorter than DS Infinity, that is already shorter than conventional guns. So we have a picture right here, side-by-side comparison of DS Trinity with the DS Infinity. It's a 20 gun system, 3 shots per foot. Trinity for the in-plane perforating versus conventional DS Infinity for helical perforating. So we can clearly see from the picture, like the DS Trinity for the same design is almost less than half the size of the DS Infinity. So this compact system design gives completion engineers a greater flexibility when designing the fracturing operations, fracturing treatments. Really, like, there are 2 options. We can either run more guns with tighter cluster spacing using the same pressure control equipment and same lubricator height, which tighter cluster spacing has been proven to be a productivity driver in some areas. Or alternatively, we can reduce the pressure control equipment, so run the same number of stages and same number of cluster per stage, but decrease the pressure control equipment, which would be a cost reduction for the operator. And last but not the least is definitely a shorter gun. It definitely has its advantages for being lighter and also easier to handle on location. So some of the other features of Trinity that I would like to mention, it utilizes an intrinsically safe initiation system. And really what the benefits of that means, a very safe gun that allows for SIMOPS operations on location, increasing the efficiency and reducing the time on location waiting for a wire line or other operations going on. Also, DS Trinity is fully factory assembled and performance assured modular gun system, 100% manufactured and assembled in a Dyna-energetic facility, which really helps streamline the well site activities and ensure the highest performance, reducing the misfires associated with the manufacturing processes on location, and obviously at the end of the day, reducing the non-productive time on location associated with issues related to manufacturing. Also, DS Trinity uses a fracture optimized charges to produce equal and uniform entry hole diameters. So this allows for equal pressure distribution across the perforation, which is essential in achieving a uniform and consistent fracture initiation, as well as better fracture propagation, and ultimately a higher perforation efficiency that we're all shooting for as far as unconventional reservoirs.
Thank you for walking us through those features and benefits. There's definitely many for DS Trinity. So do we have any examples of case studies involving DS Trinity? Any examples of some success stories involving the Trinity system?
Yes, we actually do. So when we look, there are operators in Texas that already seen the benefits of running single plane perforating both in Eagle Ford and Permian. And as a result of running all these tests, the step down test data shows higher perforation efficiency for single plane Trinity stages and less near wellbore tortuosity, supporting really our modeling and other papers and studies out there for single plane perforating. Also, the operators also seen up to 400 PSI lower treating pressure for stages using DS Trinity single plane in comparison with the conventional standard helical perforating.
So do you have any final thoughts, any final comments you want to leave the audience with?
So I guess I know we throw in a lot of information out there for single plane and DS Trinity, and really just to kind of summarize and not trying to be redundant, but really there are a lot of benefits for single plane and also for DS Trinity. And all those benefits, we can really kind of summarize them in 3 different categories as far as cost savings, time savings, and productivity impact, which they're all important for operators. So on the cost savings, some of the cost savings that are associated with the single plane approach of reducing the breakdown pressure and being able to reduce the water and chemical usage during the treatment, as well as reducing the average treating pressure by using single plane, which results in less wear and tear on the equipment and less horsepower required to achieve required treatment rates, or in some cases being able to actually bump up the treatment rates a little bit higher, considering that we have lower average treating pressures from the single plane, as well as being able to reduce the pressure control equipment by using a short modular DS Trinity system, and being able to run the same number of guns per stage, but just by reducing the pressure control equipment. The time saving component, it's really associated a lot with the DS Trinity gun by streamlining the well site activities, having already the plug and go gun system on location, and reducing the non-productive time associated with misruns associated to manufacturing processes, as well as like having a very safe gun that enables simultaneous operations on location. The productivity impact, obviously, that's a huge one, and it is related to optimizing the fracture geometry by using both the single plane and the DS Trinity single plane solution. And really, when we look at optimizing fracture geometry, we're looking at being able to decrease that near wellbore tortuosity and the pinch points to aid in fracture initiation, propagation, and fracture treatment placement. So by eliminating that tortuosity and the pinch points, really we enhance overall fracture geometry, and that has a direct impact on well productivity.
So we have had some great questions come in from the audience, from the Q&A section. So I'd like to transition and ask you some of those questions from the audience. So our first question here, how can DS Trinity match current perforation schemes? So they're asking for operators that shoot 6 shots per foot or 4 shots per foot.
Yeah, so as I mentioned, DS Trinity is available in a 3 single plane configuration, as well as a 6 dual plane side-by-side configuration. So this really gives a lot of flexibility in the number of shots per cluster that we can run to match the current helical perforating scheme. So anywhere from like 2 shots up to 6 shots per cluster, we can actually match by using the DS Trinity with those 2 configurations.
So our next question is about the charges. So what charge does DS Trinity use? And they're asking, how does that compare with the rest of the Dynastage family?
I believe I already mentioned, so yeah, on the DS Trinity, we use equal entry hole fracturing charges. And there are a lot of various charges that we have available for the DS Trinity, with an entry hole diameter varying from 0.25 to 0.35. So again, back to like having a 3 single plane or a 6 dual plane configuration, and with a variety of charges that we have available, that results in a wide range of area open to flow to match various completion treatments.
Another question that we have here, so this person is asking, how many guns have we run in a single stage?
Great question. So I guess our record today is 38 DS Trinity in one stage, and that would be in West Texas.
Our next question, so this person is asking about the distance between two planes. So they just asked, what is the distance between two planes?
It's minimal, and I wish I had a picture. I'm sure we can follow up with a better layout. But basically, the way the two planes are laid out, they're like literally back to back. And when we look at the three charges that are in one plane, the second plane, they're almost in the same plane. So I would say it's like less than 1/8 of an inch, pretty much, as far as the two planes distance.
So I think we're going to go ahead and wrap it up for today's webinar. We're about to run out of time. So Oana, thank you so much for your time today. Thank you for being here. Definitely learned a lot from all the information that you gave. So thank you. Thank you to the audience for attending and for all of your great questions. Apologies if we did not get to your question. If we didn't have a chance to answer on this call, we will definitely follow up with you by email afterwards. If you have any other questions, anything else that pops up that you can think of, please feel free to submit them to either of the email addresses that you'll see here on your screen. You'll also see a QR code to the right side of your screen. If you go ahead and open up the camera on your smartphone, if you scan this code, it will take you to a survey where you can provide us with feedback on today's webinar. We definitely love any feedback, any comments that you can provide us with, so we can improve our future webinars. If you have any suggestions, any topics that you'd like to hear from us next year, please let us know in that survey as well. And thank you everyone for attending. We definitely look forward to having you in our next one next year. So thank you so much, and hopefully we'll see everyone in the new year.
Merry Christmas.
Thank you.